Hello, Bailey and Allie. I think I have the headless teacher here, which won't matter for most of the lesson. But right now, since I won't be in until about 9:15, 9:20, I want you to go ahead and start this video and watch it. I want to begin by adding some things to our notes from yesterday, because these notes came up in our work, but we hadn't written them down in the notes. So we need to add to our note page from yesterday some concepts that we were actually using last night. So here they are, and it says the integral of k, for that's standing for a constant, and times a function, is equal to the k outside of the integral sign times the integral of the function. So, in other words, a constant can cross the integral sign. So if you would write that in your notes mathematically, and then in words as well. Then we also discovered in our work that the integral of two functions added together is the same as the integral of the individual functions added together. So we can divide this one big integral into two individual integrals, and that's true when they're added, and addition and subtraction is a special case of addition. That's not true for multiplication or division. So in words, the integral of a sum is the sum of the integrals. So if you could go ahead and write that down in math symbols and also the in words. So let me see how good that shows up. Let me zoom in a little bit. Whoops. Okay. That's pretty clear now if it wasn't before. All right, I'm going to erase that so you can pause it if you need to. All right, before I add to our time together here, I want to shine a light on the homework answers. So if you would take out your assignment and grade it, then you'll have that all done when I get in. So let's go ahead and look at that. I did my homework here, so I'm just going to pick up the video camera and shine a light onto it. And let me see how that shows up. Alright, I have to do it piece by piece here. Alright, we started with number 16, 18, 20. See if I zoom out a little, if that will help get more of the problems. Hands aren't working. Okay. If that's readable, hopefully, then we have number 20, 22, 24, 26, 28. Oops, 28 ended up down there. I worked it out and then got that answer. 30. And 32, 34, 36, and that's all we did. So right there to end it. All right, hopefully that was, I know it's a little hard to grade it against the screen like that, but if you would give that a try, I think you can handle it. All right, now I'm back on my board here. Alright, what I want to cover today is simply adding more integrals to our repertoire so that we will have a good number. So far we didn't really cover that much, and I think I can put it together in these two statements. The integral of x to the n dx equals x to the n plus 1 over n plus 1 plus c. So that was the first integral that we learned. And the other, only the other one was the integral of 1 over x, because this does not count when x is equal, when n is equal to -1, because it causes us divide by 0. So when x is -1, when n is -1, because then we have to come up with another solution, and we did that by borrowing from derivative land, and we found out it was the ln of x, but we improved it by adding more to the domain, by making it the absolute value of x, ln of the absolute value of x plus c. Alright, that looks like you can see it. Alright, so now I'm just going to go over here to derivative land, and from that borrow some more integrals, and I just will do a couple more of those and give you an assignment, and I should be in to follow up. So let's go ahead, and because we were dealing with ln, let's go ahead and deal with e. So what's the derivative of e to the x with respect to x? The derivative of e to the x with respect to x is just e to the x. So we can go over here in integral land and reverse that and say the integral of e to the x dx is e to the x plus c. So that's one of those special cases where here we have a function y equals e to the x, and its derivative is also e to the x. So that means the slope of this graph everywhere is equal to the value, the y value, which is equal to the derivative, which is equal to the integral. It's really quite an amazing thing right here. It kind of proves that there is a God. That there could be such a function is quite amazing. Alright, so let's look at the derivative of the sine of x. And from your recent math past, you know that it is the cosine of x. So the derivative of sine of x is cosine of x. So over in integral land, we reverse that. The derivative of cosine is sine. And that's a little bit tricky because we're used to getting, when we deal with cosine first, if you recall, the derivative of cosine, which we're going to talk about in a second, is negative. But notice the integral of cosine is positive sine because it's working this backwards, and these are both positive. So now, when we go over to take the derivative of the cosine of x dx, we're going to get negative sine x. So the integral of sine x, notice I didn't take negative sine x because you might be confused where I usually take the answer here verbatim from derivative land and make it the problem in the integral land. But I don't want to start my integral with a negative sign. So I'm just going to pop the negative sign over here. So instead of getting cosine, I'm going to get negative cosine. So that works quite the opposite. The derivative of sine is positive cosine, yet the derivative of cosine is negative sine. The integral of cosine is positive sine, and the integral of sine is negative cosine x. When I forget this, I seem to have memorized this, it probably sticks, but when I'm taking an integral, I always look at my answer, and in my head I take the derivative, which sticks quicker than the, or longer or better than the antiderivative. So when I just take the derivative of that in my head and see if I get back to where I should. And then I know I've got the SIG and the positive or negative part correct. Alright, now here's some integrals. I'm interested to know if you know the derivative of the tangent of x dx. You should know that. And it is the secant squared. And so that tells us that the integral of secant squared x dx is tangent x plus c. Alright, we just have a couple more of those to do. So, oh, excuse me, I gotta turn off the rice. Let me go ahead and give myself some room up here. I'll leave all the trig, try to leave all the trig up here. Get rid of some of these newer ones that you've already written down. Alright, so now I want the derivative of, which one shall we do next? I think I did secant next. The derivative of secant x dx is, I'm interested to know if this is familiar to you, is secant tan, secant x tan x. So the integral of secant tan is secant. These are some relationships that if they aren't memorized yet, you should commit those to memory. So the derivative of cotangent is negative cosecant squared. So the integral, once again, I'm going to, instead of putting the negative sign in my integral, I'm going to flip it over to the other side. And I'm going to get negative cotangent. So now I have one more to do, and that is the derivative of the cosecant. And that is, the answer is negative cosecant cotangent. So the integral of, and again, cosecant, I'm going to make it positive. Cosecant x cotangent x equals, dx. And that is going to be negative cosecant x plus c. Alright, so those are the trig ones that we can do. So I just want to point out before I go on and give you some problems to do, that these integrals are very restrictive. You can only take the integral right now. The only thing you can do is take the integral of the cosine of x, and it looks just like that. If it says cosine of 3x, no go. So it's got to look just like this. And you can't take the integral of plain old secant x. It's got to be secant squared, or it has to be secant tan. Sometimes we'll give you one that doesn't look like this, but with trig IDs. One of our favorite things to do is use our trig IDs. You can rearrange it to look like one of these, but for now, you're very much restricted by these exact forms. Alright, if you would, take out that paper from yesterday, the homework paper, and I'd like you to go ahead and do all the trig ones so they don't have too many of them there. I don't have my book in front of me. I'm assuming it goes from number 33 to number 44. Now I have the second page of that, where some of them are on the page that you don't have, so let me get that and I will shine a light on it. And that's all for this video, and I should be in if I'm not already. So I'm going to get that paper. Finding that paper just now. Well, start on the trig ones there that you can do. And I will have to find that other paper. I believe I put it in with my Calc 2 stuff. I don't see it there either. Alright, well I have it somewhere. Go ahead, you won't be able to go up to 44, but do all the trig ones on that page and I should be in very soon afterwards. So on the homework paper that you started last night, go ahead and do all the trig ones, the even and the odds. I think it starts around number 33. Alright, have a good time till I get there. Bye.